Let's have another example of t-test of independent means. Let's have this problem. The weights in ounces of a sample of running shoes for men and women are shown here. Test the claim that the means are different. Of course, we're going to use the p-value method with alpha is equal to 0.05. So, pause the video and try to do the t-test of independent means on your own. So, of course, since we're going to do t-test of independent means, we have to make sure that we have two groups. And we have men and women. So therefore, we can really use t-test of independent means. So we can now go to step 1, which is stating the null and the alternative hypothesis. So, taking a look at the claim is that the means are different, which means the mean of the men is not equal to the mean of the woman because they're different. And since it's not equal, this should be for the alternative hypothesis. Hence, we will have the mean of the men is not equal to the mean of the women. Therefore, our null hypothesis would be the mean of the men is equal to the mean of the women. So that is our step 1. For our steps 2 and 3, we would need now to use Excel. If you would remember, before we actually do t-test, we need to do Ftest first. So, we'll go to data analysis, and we shall select Ftest. So, going back, we will need variables 1 and 2 and our alpha and the output range. So, variable 1, we'll select men first as these are the ones given first. Then variable 2, women, because the women are given second. Labels are there, alpha is 0.05, output range, we'll just place it here for now. Then we click OK. So, taking a look at the variance of the men is bigger than the variance of the women. Since this is our variable 1, we are correct and we don't need anymore to redo the Ftest. So, let's now look at the p-value. The p-value is almost 0, 0.00. And, as we know, if the p-value here is less than alpha, then we will use unequal variances. But if it is greater than, then we will use equal variances. In this case, the p-value, which is almost 0, is less than 0.05. Therefore, we will use unequal variances. So, now that we know we will use unequal variances, we will now go to data analysis. T-test to sample assuming unequal variances. Click OK. So now again, we would see the following that we would need to put there. So variable 1 is the men, because that's our variable 1 here, should be the same. So variable 1 is men. Variable 2 here should be women, because that's the second one in our Ftest. There, we will not put anything in the hypothesized mean difference. The labels are checked. Our alpha is 0.05 and our output range, we'll just put it here. Then everything's okay. We will click OK. There we go. I'll just fix it a little bit. That's too long. Alright, here we go. Let's just place it a little bit on top so we have space to write on. And there. So now we can proceed to step 4. So in step 4, we would need now to compare. But to do so, we have to go back to our alternative hypothesis. Again, this is not equal, therefore this is a two-tailed test. So therefore, we shall look for the p-value for two-tailed. Go a little bit to the side. There we go. Oops. There, we fix it. So the P for two-tail is actually this one, 0.000343, which is almost 0. So the P, which is almost 0.00, I forgot that symbol there, is obviously, when we compare to 0.05, this is less than 0.05. Therefore, we shall reject our HO. So our conclusion will be there is sufficient evidence to reject HO. Therefore, the claim that the means are different, is this true or not? Since we will reject HO, we shall go to our alternative hypothesis. So is the claim that the means are different? The claim, capital C, is correct. That is the answer.